Hey there, welcome to the Posit Data Science Hangout. I'm Libby Heron, and this is a recording of our weekly community call that happens every Thursday at 12 p.m. US Eastern Time. If you are not joining us live, you miss out on the amazing chat that's going on. So find the link in the description where you can add our call to your calendar and come hang out with the most supportive, friendly, and funny data community you'll ever experience. Can't wait to see you there. Well, with that, I am so excited to be joined by our featured leader today, Frank Hull, Director of Data Science and Analytics at ACES. Frank, I would love it if you would introduce yourself. Tell us a little bit about you, what you do, and something you like to do for fun.
Yeah. So I lead a data science team in energy, which is a lot of fun. We get to solve a lot of difficult tasks. Also, for fun, I have a lot of different hobbies. Right, I kind of think of them as like cyclic. So right now I'm really into gardening. It's kind of taking over right now just because I'm in the middle of summer in Colorado. Um, But other than that, I spend a lot of times outdoors. So hiking, climbing, camping is a big part of my life. Also really into playing guitar, and I've been learning drums over the last few years. I'm kind of a musician first before I ever got into math or data or anything like that. Um, Maybe I always try to think of it. I'm like, why do I like number patterns so much? I think it's just because I studied guitar tabs so much in like middle school and high school just to like learn new songs. And then like started noticing number patterns and I was like, oh, I'm gonna get into math. But um, other hobbies, I'm kind of went back and forth from like home brewing and doing other stuff like that. I have two sons, so three and one. So mostly playing with monster trucks and Hot Wheels in my free time. Um, and then, um, I'm also like been working in open source software a little bit here and there, kind of building packages out in R, posting those on GitHub, and just kind of talking about it on Blue Sky or X or something like that. So kind of like a hobby of many hobbies. And then kind of goes back to my team. I think we're all kind of full stack data scientists. So we all do a little bit of Shiny, do a little bit of data engineering, do some machine learning, and everything in between. So um, yeah,
Awesome. Well, I want to dig in a little bit to what you do and give everybody a little bit of context so that they can ask good questions in Slido, because not everybody kind of knows a lot about energy markets or the energy industry. And when I learned what you do, I was shocked because you told me that your team oversees over 1,000 models. And I was like, excuse me, what? Did you just like, was that a verbal typo? 1,000
yeah,
models? Like more than 1,000 models? Why do you need that? But then you explained it to me and it
yeah,
made perfect sense. So I'd love it if you could talk a little bit
yeah,
about that.
yeah, totally. Yeah, so like we're in wholesale energy. So like ASIS is an alliance of cooperatives for energy services. We have a whole um, kind of menu of services that we offer from front office to back office. I'm in front office. I support our portfolio management team, our portfolio strategy team, and our portfolio modeling team. We also have resource planning and fundamentals and a capacity team. And then we kind of like bounce ideas back and forth with the transmission team. So that there's like all these different teams that are like supporting these co-ops. And really we're trying to lower their variable cost, but also understand the risk associated with the portfolio. And like you would think you could set up like one model, but like just like the whole fact that the United States is split up into different ISOs and they have different regulations, they have different resource mix. They each one of our portfolios could be in a different area of that ISO, and that brings on different challenges. So, we're simulating over 40 portfolios, and then each of those have their own, maybe more than one load. Whenever I say load, I should stop. So like load is being like a demand on the system. So it's kind of a supply and demand problem. Um, and you need to serve this load. And they might be in an area of the country that has tons of wind. They might be in an area of country that's like natural gas and solar and battery. And all of these things create different issues with the way that you can kind of create a supply mix to serve that load.
We
Um,
have a quick question to interject. What's ISO?
yeah, it's an independent system operator. There's a lot of acronyms in energy, so I'll try not to say too many, but please
That's
stop me if I
okay.
do. Yeah.
So I think that the gist is there is so much variation across a region, across a town, between towns, not only in the energy that they demand, but also the energy that is available to be consumed, right? So
Yeah.
you've got to model, for example, the San Antonio metropolitan area where I live. Like how much are we going to need? And you go out a pretty far time horizon, like 25 years, right?
Yeah, yeah. So whether you're regulated or not, you kind of want to have an idea of what's going to happen in the next hour. Or then, you start thinking, you're like, I want to know what's going to happen to in tomorrow. So there's a day ahead market. And then when you're like doing financial planning and analysis, you want to know what happens next year. But then like when you're talking to a city council or like talking about putting new steel in the ground and you're trying to defend whether or not to build a new um, combustion turbine in this area of the country, you kind of need to simulate out 25 years to understand like what the hourly price shapes would be, what the hourly demand might be in that area, what the supply mix is going to be, and then, whether or not that particular hedge or new generator would even be useful in that area of the country. So you start like, you're like, I want to know what happens in the next 5 minutes, the next hour. I want to plan for tomorrow. And then you start like getting everyone in on the company and you're like, okay, well, we need to like plan years ahead of time. And the independent system operator is also, a market. So it's like trying to also help that planning, but there's also non-ISO areas of the United States too. So regardless, like you kind of don't want to have a blackout. So how do we like
Right,
mitigate
yeah.
that? And
You don't
also,
want what happened in Texas in 2021.
yeah, yeah, you don't want to run out of supply when there's high demand. So that's a huge issue, especially
Yeah.
as demand is increasing across the United States.
One more context building thing that Frank had told me the last time I talked to him that I thought was really interesting was that some regions have surplus energy and that the energy price can actually be negative. It could be like you could have a price for energy that is zero. That kind of blew my mind a little bit. Like if there's an area where there is a bunch of wind electricity being generated, right? But there aren't a lot of homes there consuming that power. Where does that power go? And how do you make sure that it ends up where there are high population density areas that really need that? That's a really tough problem to solve, isn't it?
Yeah, yeah. So, and you can think of this as not like anyone's fault, but like, wind just blows more in Kansas, Oklahoma, Minnesota, but not a lot of people are in those areas. So then you have to build transmission to get it to the demand. So, um, Kansas City being really far away from Western Kansas where you see tons of wind farms. So how do you get that wind power over to the people? And within like, the market, it's designed in a way so it's going to decentivize supply where there's already tons of supply and no demand. So you'll see prices go negative around renewable generation where there's a pocket of renewables and they haven't quite built out the transmission. So yeah, you start simulating, you come up with like a vanilla model and it starts to work for everywhere. And then you start running into these edge cases and you have to build new models to handle these different nodes. So that's where you end up thinking, I have one model to simulate, top down. I'm just thinking total load of the system, total wind of the system, total solar penetration of the system. And then you're like, okay, I got a pretty good net load model for the entire system. Um, but then when you start getting into the nuances of, hey, I need to simulate this in one node for this portfolio, and happens to be a wind turbine and surrounded by other wind turbines. And you're like, how do I create a price shape for that location? it could be negative quite often. So yeah, there is like this really interesting markets plus energy plus like physics plus engineering that all goes into it. Um,
Yeah.
yeah.
Yeah, and for anybody wondering, Frank's background is physics, but this does seem like a lot of like finance, economics, mechanical engineering, even a little bit in there, electrical engineering. Well, we have so many good questions in the Slido. They are stacking up like crazy. So let's see if we can get through some of them. Thank you, everybody, for asking your amazing questions. And the one that I see that I think would be great to start with is from Edward Leland. Edward, are you available to unmute and ask your question live? If so, I think it's going to cover a couple of other questions. Like I know Arsenis had asked one that was really sort of in the same line. And so I might add on a little bit of Arsenis's to yours.
All right. Yeah, sounds good. Hey, I'm also a physics background person. That was my undergrad. Was a
Nice.
double major in physics comp sci.
Oh,
Good to
awesome.
know other people got out of physics and are doing comp sci stuff. It's I don't know, it broke my brain. Anyway, sorry, here to the question. What are your go-to models for analysis in your field? Because you got like 1,000 plus. Do you have to evaluate every problem like individually, or do you have like a class of or type of models that you get to use for a lot of different applications?
Yeah, that's a good question. Um, you know, when you I think you have like a class by maybe like fuel resource type. So like we have a few engineering models for like wind turbines, and that might change depending on what kind of turbine blade is on the particular um, wind farm or what the manufacturer is. Same with like solar, depending on where it's located, and you have like an understanding of the kind of solar irradiance in that area and what kind of panel it is. We have pretty good engineering models for those as well. When it comes to like kind of coming up with like demand profiles and um, price shapes, you can start trying a few statistical methods, but I think you end up kind of doing a few different machine learning methods. So that, tree-based, rule-based, linear models, polynomial models, those work pretty well, depending on how you kind of feature engineer. So I think that's kind of where it really helps to work with the business. So like that's where my team's kind of working with all these portfolio strategists, portfolio management teams, where they might see and have a hunch on like, hey, this is what's driving this congestion. I think that's what's driving this negative pricing. And then you're working with them and kind of feed that into the model, and then the model picks up on the price patterns. So um, that's kind of our methodology. My team, we're using tiny models for 80%, 90% of the models that we're building, doing everything from scratch. So yeah.
That's
Um,
awesome.
yeah. Yeah, there's a few other resources in Python, Julia, and R. In Rail, they make a lot of toolkits. And then, when you're sometimes I say model a lot, so I'm always saying like regression model, but then there's the portfolio modelers that have a portfolio model. And then, I'm talking to IT about models and they're like talking data model. And I'm like, okay, I'm talking about regression model here. The portfolio modeling team has their own software as well. And that's kind of putting together all of the P&Ls off of the loads and the supplies and stacking that and coming up with the average variable cost and risk associated with
Yeah, lots and lots of the word model getting used in different terms. Well, I wanted to tack on Arsenis's question. Arsenis, I hope you don't mind if I grab some of the bits of your question and ask them here. Okay, good. Because he had asked in the same vein, like, do you tend to use traditional stochastic models for time series analysis or more of the recent ML methods in time series analysis? I'm also curious about whether you have used LSTM, which is long short-term memory, for longer term predictions and how that has performed.
Yeah, that's a great question. Um,
I'll
we've
let
moved
you.
away from Monte Carlo. So
Okay.
I would say 10 years ago, I was doing a lot of Monte Carlo stochastic simulation. So I think the problem is like with when you start introducing, when you're in a transitional time. So you went from just like, all right, is coal or is natural gas cheaper? Then we know which plant is going to run, and we can kind of simulate those commodities and come up, multiplying by the heat rate of that power plant, come up with a power price. And you're kind of chasing that. Then now we started introducing wind, and it's taking over like 50% of the load, and then you start adding solar and then batteries, and then you have like these price shapes that just for a Monte Carlo simulation are just the tails are too fat and long. So we start doing machine learning everywhere for stochastics. So starting with, you can start really simple. Just take like one weather day and just trying to understand like what one weather day, what are the options for a wind profile, a solar profile, and a load profile. And then you can come up with the net load and the subsequent price shape. So then I say that one weather day, then you can just do that over 1,000 times, and you have 1,000 load, solar, and wind shapes. So I think that's kind of like where we're moving towards as an industry standard. I see that across other companies. There's at least like 7 out of the 10 companies that I know are moving towards that or already there. And then that's where we are, and we're providing the service for over 45, 46 energy companies across the United States. So I think everyone's more inclined to like saying like, hey, $1 billion extreme weather event disasters keeps increasing over time. That's like, I think all of the risk is associated with weather. So trying to understand that and starting from that framework instead of just a simple Monte Carlo simulation. That's a great question. And then
Yeah.
LSTMs, we don't use those. I
Okay.
worked with Purdue and their geo data science department on testing out a few in MISO. Just the complexity and then the computation time. And then I just don't think for us, we don't have our data like normalized and stationary enough for that to be scalable across all the data. Tree-based model or rule-based models better for that, in my opinion.
Okay. Very good to know. This is really good information for anyone who's like, where can I do this in practice? Like I learned all these things in grad school or undergrad, and I kind of want to do this. The energy industry might be a place for you, right? We had a couple of questions in the Slido that were about like what is a full stack data scientist? I think Noor had asked, and Abigail as well. Abigail has a little asterisk by her saying like, hey, I can't ask this right now, so I'm going to ask it for her. But I wanted to give sort of you the chance to talk a little bit about your background as well, because you told me that you learned you this is such a backward experience from what I normally see for everybody. You learned like Python in undergrad, you got out into industry, and you learned Excel in industry. You were like confronted with huge Excel files, and then your IT department asked you if you know R. Now, every IT department that I have ever talked to, I have been trying to convince them to let me work in R, not the other way around. So, if you could talk a little bit about how that happened for you, and then the question from Abigail and I think from Noor as well was like, what does full stack data scientist mean to you? And like, how do you explain that you're a full stack data scientist to someone without confusing them?
Yeah.
What's the overlap between like a full stack data scientist and something like an ML engineer or a data engineer?
Yeah. Yeah. Those are all great questions. I was scrolling through here and I didn't realize how many people were here. But I was looking for the person that recommended R, see if he was in here. I don't think he is. He might be. I could have skipped over his name, but yeah, we have a short-term analytics team, and he had led analytics services, part of IT, kind of being that arm to help out our term training and stuff like that. And I looked over my shoulder one day and it was just like, hey, like, see you messing around with VBA. Have you ever heard of R? And I was just like, no, I've never heard of R. Like I was someone that like if I ever had to like find the max in a vector, I was like creating my own algorithm to look for a max. Like I didn't realize people use the form like just max in Excel and like use max and R. I was like, whoa, like you had to like already have half of the problem solved for you. Yeah, so like from physics, like I was like learning C, Fortran, Python, and I got into business and I was like, what is like Excel was like a way for me to do data entry in a lab and then take that back and like write a report. Like I never had thought that someone could like build a full model in Excel or like I didn't know what SQL was. So I was like, what is this? So I like learned all of that and like data science wasn't like a degree or a program when I went to college. So it's just something that I happened into because I kind of really liked simulations. Like that was what I wanted to do. I didn't even necessarily want to do physics. Um, I was like concentrating in engineering, but had a CAD minor and then computer science on top of that. And I was just like, if I learn all of this, maybe I'll be able to do something. So at that point, got into industry. I already felt kind of like I had like a little bit of everything going on. And I hire people like that I can see can like do multiple tasks. And I think of like our whole team as being like a knowledge sphere. If someone can come in and add to that knowledge sphere, that's great. And then if they already know other pieces of the knowledge sphere, that's awesome. And I think we can all share that knowledge sphere with each other. And that's where it's like, I think I might have our manager of data science here. He's an ML engineer pretty much, but like he's a manager of data science because he's seen enough across the whole spectrum of data science. And then like my lead data scientist, he might be in here. I saw him of himself. That's like a funny character in this group. I was like, that's probably him. But he's almost more like also a data engineer. He's also a plumber, building plumber APIs all the time, building shiny applications. He's also like scheduling and automating tasks on cron with our new data analyst that we just hired, and she's been doing unit testing, and she has more of a software engineer background. And like study stuff that I've never learned. So it's like we can come in and all have like different backgrounds, but like teach each other the other aspects. I have another data scientist that we just hired. So I like my team's growing this year. So I have quite a few new people, but she had been a data role where in a company that everything came back to her. And from agile development to like what data's in the database to how do I build a, predictive algorithm on top of this. So like I try to like I think like full stack is like maybe you have like maybe you're not perfect and shiny, but how to build a shiny app. At least with the proper tools. Like maybe you can't do it from scratch, but you know how to use Shiny Assistant and like get an application going on top of your machine learning algorithm. Maybe you don't know a ton of machine learning, but you can lean on someone else and learn quite a bit on the team. And so then you end up within a couple of years, you know a little bit of data engineering, a little bit of ML engineering, a little bit of Shiny application development, and then like launching an API and doing automation. So I feel like every person has a strength and weakness too. So
That's great to know because there's an anonymous question in the Slido that says, is there a specific data science skill set that's needed to get into energy analysis? So time series, but like, is there anything else? It sounds like there's room for a lot of different skill sets.
yeah, there is. So like if you're like just really good at SQL, I think there's opportunities. And then my team is leaning more towards machine learning and working with the business, but there's other data scientists in our company that work under IT and like handle other processes, So I think if you want to get into energy, um, you know, I think it's kind of just like a little bit, maybe learn a little bit about simulation, a little bit about like Monte Carlo methods. That'll get you in the door, knowing some SQL. Um, there's there's just so much, like so many different avenues to like get you into the door too. Because if you have an economics background, you can start off as a real-time trader and then kind of like edge your way into a company that way too.
Yeah, you had mentioned at some point working at an energy trading desk, and I was like, wait, what? Were you a finance major? No, you were a physics major.
Yeah.
So I thought that was really interesting that there really is a lot of different skill sets being smooshed together, um, and they all benefit the team as a whole. So thank you, anonymous asker, for that good question. And we have one other question that is just kind of adding on to that, which is clarification. What is a portfolio model? You've said portfolio model a few times.
Yeah. Yeah. So a portfolio just being like a company, or, when I worked at in the past, I've worked out of a company that had all of their portfolio as each of their LLCs. So kind of it could be with or without a demand, but with at ASUS, it's a company. So it could be a city water and power. It could be just like some energy company that serves part of Texas, or it could be an energy company that just basically has been around for 15 years to 50 years, and they have maybe they have a coal plant, maybe they don't, maybe they have 5 natural gas turbines, maybe they do or don't. Maybe they're in an area where they just purchase bilaterally off of other counterparties and they don't own any resources at all. The portfolio model is designed so you can kind of understand what their more or less like monthly average variable cost and risk associated with that variable cost would be. So you're still like doing you could do a Monte Carlo or a machine learning stochastic simulation of all of the wind patterns that their wind turbines would fall under, all of the solar patterns that their solar farms would fall under, and their loads associated with that, and then all of the price shapes that you would multiply these volumes by. And then you kind of come up with this, this risk associated with, hey, like on average, we see the cost of this portfolio, this stack of resources. We see, the cost of this portfolio being $30 per megawatt hour for this month. But there's like it could go up to $75 per megawatt hour if this scenario happens. But that's only 1 in 100 scenarios. So
Awesome. That's a lot
that,
of variables.
yeah, yeah.
It's a
That,
lot. And also, like, we didn't really even talk about all of the different types of energy that could go into a portfolio, right? Like, there's wind energy, solar energy, coal, natural gas. Am I missing something? Hydro, maybe?
battery, yeah, hydro, battery. Um, and then there's options and like bilateral purchases. So like, if I just want to serve my 1,000 megawatt town, I only have 950.
Hmm.
I could either serve that leftover 50 megawatts by the market, maybe multiple markets. It kind of depends where you are like in the region of the country and where geographically you're located. But um, or you could purchase that off of someone else. So then
It's
it's
wild that you
fixed.
can like have no resources yourself and just purchase them to re-offer them. That's really cool. Well, I want to get to another question before we go too
Yeah.
much longer on this one because we have so many good questions. We're not going to get to them all. But Thomas Wells had asked a question that I thought was really, really great. Thomas, would you like to unmute and ask your question?
Sure, I think Rachel unmuted me for me.
Yeah,
Thanks.
fancy.
My question, I've had experience trying to convince regulators to use machine learning models in situations that are very statistics heavy in the energy industry. And so my question is, how have you found convincing regulators and other like stats oriented stakeholders to trust and believe your AI fancy machine learning models that they can't really dive in and prove to themselves as being statistically valid? Or have you found some good ways to demonstrate that?
Yeah, those are good questions. I guess it depends if you're regulated or not too. And I guess are you trying to like convince an ISO, or are you trying to like defend your method in front of a city council? That was a
My
question.
experience has mostly been in verifying energy efficiency measurements,
Okay.
savings associated with energy efficiency measures. But I'm more interested in your experience, both talking with regulators and other folks that are maybe more less regulatory driven, but also have an interest in ensuring that your forecasts or predictions are accurate.
Yeah, yeah. I mean, it kind of depends. Like, um, for the most part, I haven't had too much like pushback for any of our methods. Um, we have developed white papers, so like that's something that I think like if you do have to defend yourself in front of like a city council, or going to an ISO and trying to like submit your long-term load forecast and saying, hey, I deviated from your methodology a bit because I was trying to capture this, and then like trying to like have that presented in a white paper. I think that that goes a long way. And I think for me, and telling you, like white papers are really hard to do too, especially if you're like constantly changing your algorithms. So using, packaging everything and using version control goes a long way. And then, making it so like the white papers automatically get built within the package down is really nice. So like I've been going from like over just the last few years, just going from, hey, I wrote this algorithm in a script. This is a really cool script. Here, take this script. And then like people start editing it, trying to change it for their one goal and purpose. And I was like, oh crap, now I have to manage all these scripts. And then, going and then being like, oh, well, maybe I should make this into a function. Um, Eventually we are just like, we needed to package everything. So I think just starting there first and just like defending everything with a white paper is really goes a long way. So I think that's probably the best way to counteract that.
Awesome. Thank you. And while we are talking to Thomas, I figured I would just touch really quickly on the fact that there was a question anonymously asked about, are there any good examples of like open data in energy? Thomas had answered a couple of different options. I'm going to put all of those options in the chat here. Not all of them are from Thomas, but a lot of these are just replies in a thread in Slido. So I wanted everybody to see them in the chat. So thank you to that anonymous asker who asked about data that you can use to learn. And thank you, Thomas, for the wonderful question.
Libby, I was just warning you, your video went off, and I am just telling you because I accidentally used a Zoom shortcut that was making that happen to me
I
too.
bet it did.
Yeah.
I pressed something on my keyboard. Thanks for letting me know.
When I was like copying and pasting the other day, I noticed that happened to me too.
I wonder what that is. Somebody go Google Zoom shortcuts and tell me what I'm pressing wrong. Okay, so there was one other question that I am also curious about, which was like, how are you keeping on top of the documentation for all of these models? Over 1,000 models is a lot. Is there any learning you could share from that experience to help other people keep on top of their documentation?
Yeah, yeah, and I feel like at least for like a white paper standpoint is like having it for like kind of your overall process. And then for like a detailed down to the model, I tried like a few different tricks like model scorecards and stuff like that. Making something, and I'd say that this is constantly changing too. So like if anyone else has ideas to share, like that's totally cool. But like keeping like an ID for every single model, and then having like all the information there that's like valuable to your team, but also maybe to the strategists, maybe to the modelers. So like what what was the start and end date of your training data? Simple stuff like that helps. What was the out of sample score on your test data? Stuff like that. And then you can kind of save off model objects and come back to them if you need to. And I know like some industries are way ahead, like in health, like care and stuff like that, where they're using targets all the time. I know that that can be beneficial in some places too, where you can also come back and see when the model was trained, and if the new data wasn't added, then you don't need to retrain the model. So you basically just need to build data catalogs for everything, which was kind of like eye-opening too for me too, because like I came at it like, oh, we can handle this, and then like have that technical debt and have that conversation with the team where like, hey, no, we actually do need model scorecards and be able to have monitor the model health. We thought we could skip over it, but you'll come back to all these things later. Even like functionizing and putting every function into a library, like that saves you so much time.
Yeah, Brajesh had said in the chat, like using Quarto websites to document the groups of models. That's such a great way to use Quarto that like I hadn't thought about yet.
I don't know
Now,
if it's the same exact thing, but I know Julia Silge led a workflow demo on model cards. Is that similar?
oh, I don't know.
It's like, yeah, and that's so we have our own like model card, but like, yeah, using vetiver and pins
Hmm.
is like another route that you can go. I'm also like signed up for this workshop for the orbital because I'm like, I might use that some places. I don't know.
Yeah. Do you all
So
use Snowflake or no?
no, we do not. But I still think there's like quite a bit we can learn from that
Yeah.
whole concept. Yeah.
That's what I've been trying to tell people. They're like, oh, I don't use Snowflake. Maybe that's not going to apply to me. I'm like, just go learn about the orbital part of it. That's going to
Yeah.
be the like really big takeaway. And if anybody is curious about orbital, it's basically like, hey, you've got these models. They could be basic models, they could be complex ML models that you can just orbital can translate them into SQL to be run in SQL on your SQL database to speed things up and be very magical. If you're looking for the talk where this was talked about initially, I think it was Emil's talk last year at Posit Conference. Um, so maybe somebody can go find that stick it in the chat. I wanted to move over to Connor's question, and Connor has a little asterisk saying, please ask this for me. So I am happy to. So Connor Tompkins asks, how would you suggest handling missing data in time series forecasting? And by the way, there was a whole like smote question in the chat with lots of replies. I think Mark was helping out with that question. So feel free to add more info here. Raise your hand if you have any. But for example, if there is a blackout, that demand is censored. So would you impute the missing data with another time series model and then fit a final model based on that like actual plus imputed data?
That's a good question.
Or do
There's
you
like,
impute at all?
we do have some tools to impute, but I hardly ever use them. But
Mm.
the team could probably interject and be like, Frank, don't say that. I use it like every day. But no, there's like it's a two-sided issue where you have issues and zeros being like associated with energy data is like all the time, like daylight savings time is very annoying. And then, or daylight savings time is very annoying because it doesn't skip an hour, but like duplicates, like just sums the total of the 2 hours. And you're just like, you need to like smooth some spikes out of data. Like EIA data is sometimes horrible in that regard. Like it's just submitted to the EIA and it's just like, it's a free data source. So I might have used it a few times, but the amount of cleaning that you have to do is immense. But like for zeros, it kind of depends. Is it 1 hour? All of our models are hourly. So I didn't really preface that, but like all of our models are pretty much hourly models. If it's 1 hour versus like 2 weeks, we use different imputation technique. So, if it says 1 hour, like you can just kind of smooth it with the average of the 2 on either side. That's pretty naive, but it's pretty much acceptable. But I mean, if you're missing like a week or two, then you might need to come through and like impute that with a separate model altogether. And then depending on, yeah, if it's 1 day versus 2 weeks, how complicated of an algorithm you're going to use.
Right. Yeah. And there's also some pretty good papers on smote and maybe why it's not the greatest thing to use. So those are
Yeah,
things I would go look out for and read.
yeah, I didn't see. I've been trying to keep track of the chat, but there's no way. So
No
like most
worries. Don't worry.
most of it went right past me. I didn't see the comment on smote, but I do not use smote anywhere. If
Yeah.
that helps.
All right, well, we have about 10 minutes left. Let's see if we can get a couple more questions in here. And let's see, I saw Ross ask one, Ross McKinnon, and it also has an asterisk, so I will ask it for him. Do you see long-term electricity prices decreasing in the next 25 years due to the abundance of renewables like wind and solar in lower population areas? What a good question, Ross.
Yeah, this is like something, I've talked with many people from many different companies. I'm waiting to see who's right, but I think overall, like, it's not a secret. I think everyone thinks it's trending downward. But it's like there's also like ancillary service prices too. So I skip over those a lot, but like um, you know, if wind's serving your load and then you have a lull, like what solves for that lull and wind? And it could just be for like 30 minutes. So you need to have like some sort of antithetical response to that to keep the frequency of the grid constant. So like right now, that's normally natural gas. Um, in the long term, you have wind and solar. You have so much solar. You have so much battery that you can start to flatten out prices. Prices should trend towards zero because the energy cost is zero, but then there's like the maintenance of the solar and the wind and the transmission grid that does cost money. But I think what will happen is you start layering in and everything starts trending towards zero, but also gets more volatile too. So like maybe prices are typically zero, but could bounce around to up to $100. I don't know. I just pulled $100 out of my hat. So any kind of like, hey, we're typically averaging $30 now, standard deviation of 1. Maybe it goes to 0 and standard deviation of 2 or 3. So we'll see.
Complicated answer, but it's a good question. Thank you so much, Ross, for asking that question. And I wanted to ask kind of an overarching one or two for the last little bit here, because we usually ask a career advice question. So really quickly, do you have any career advice? And then I'll hop to one last one to wrap us up.
Yeah, career advice is like interesting. So like I feel like um, I've always led data scientists, mathematicians, statisticians, kind of people. So I am typically lean introvert. So I just say like get out of your chair throughout the day and like just go talk to people, tell them what you're doing. Just like go and talk to an executive. You're gonna feel so awkward and uncomfortable probably, but like just get up from your desk and go and like quit playing with data for 5 minutes. And then also like the other thing too is like, these machine learning algorithms, like I could spend like months trying to tune a model, or I can just say, hey, it's good enough. So like understanding the business is probably like, hey, I just need it now. And if it has a
Right.
MAPE of 6%, let's just go because, if it takes you 3 more weeks to get down to 2%, like I don't need it by then, I need it today. So like
Right.
understanding what your business threshold is for that accuracy and knowing how to communicate to them too. So like business leaders like to use MAPE. we don't train our models with MAPE, but when I communicate to them, I say MAPE. So.
And MAPE for anybody is MAPE, mean absolute percentage error. So that's like accuracy in a forecasting model, and sometimes it can be a little bit more accessible than some of the other things that people in the data science side might be using. I think that's great advice. And the last one to lead us out here, Zach asked a fantastic question. Zach's one of our regulars here. And I think it's a good one to talk about, like what you're excited about. It is, how do you see data science evolving within the energy industry? Is there stuff that you think that's happening that's cool and new? What are you excited about?
Yeah. I think it's like constantly evolving. Like I think like 15 years ago, you wouldn't need to build this complex of models to handle the simulations. And then 15 years from now, I have no idea what might occur in energy that might make it twice as hard, but we'll have twice as much compute. So we'll see what happens. But, like also another crazy thing in energy right now is bringing data centers back to the United States to train artificial intelligence, which creates so much demand. And then it's like, okay, well, now I think like the next 5-10 years is like, how do we build out enough supply to serve this demand? So it's constantly changing. There's always new risks and always new problems to be solved. I think, what was it? I think Thomas brought up energy efficiency. Like that's a huge problem in itself. It goes all the way down to a house level and trying to simulate like every single appliance in someone's house and like understanding how that changes over time. So that stuff's pretty crazy too. Yeah.
This is a follow-on to this. If anyone did not attend Sajay Suresh's episode from Microsoft, Sajay is a senior director of applied data and or applied science and data at Microsoft. But Sajay works on forecasting demand for these data centers. And that's a really complicated and hard thing to do. His episode was fantastic, so go watch that one. And then I wanted to give Rachel a chance to ask a question and also mention really quickly that Frank also does open source package creation. And I think Cusco just came out. I love the name Cusco because I love the Emperor's New Groove. I don't know if that's why it's called that, but it's a package for R to help with computer vision, right?
Yeah. And I don't know if Isabella's here, but thanks for the mug.
Yay, awesome. Yeah, Isabella might share that in the chat. All right, Rachel, what did you want to ask?
Oh, I was just curious, Frank, because you mentioned a few different packages like tidy models and targets, and you heard about the orbital package too. Like, how do you keep up to date on new packages? Especially for me working at Posit, it's always really helpful for me to hear like how people find out about things.
Yeah, I don't know if everyone wants to know that I stay up all night just like surfing all of Posit's websites and keeping track. Now, like, like sometimes now that I'm more familiar with GitHub, sometimes I like will peek at one of the packages and see if it has any merges lately, and I can kind of get ahead of like a CRAN release, which is kind of fun. When you're on to something like that, like Mirai with her. It was something that my team and I was like watching for weeks, and I was like, is it going to get posted to the CRAN this week or next week? Like, when's it going to happen? So like I'm on Blue Sky. I'm constantly watching any new releases from like Simon. I follow him, I think everywhere. Simon's on the Tidy Models team, but also leads like tons of LLM stuff. So
I just saw Simon's here too.
Simon's in the chat.
Oh,
Yeah.
it's awesome.
Oh, weird. I've never actually talked to Simon face to face.
Simon, I guess we have to unmute you then.
I guess you have
Celebrity
to.
spotting.
Simon.
Yeah.
Thanks for being cool.
Yeah, that's so cool. So like just following a few of the software engineers across Posit is a great resource. Just following the boots on the ground, going straight to the grassroots and just like following the people that are building. I think that's where I get most of my information.
I love it. Say their names and they appear. never know. You never know who is out there in the Hangout, right? We have over 100 people. Usually we have about 150 people lately. So somebody might be hanging out and listening. Well, I want to wrap up and let everybody know who is coming next week because I am so excited to have Jenny Bryan next week. Get your laptop on fire merch ready and come hang out with Jenny and everybody, and we'll talk about all kinds of good things. Um, get your PositConf registration in. There is still time to book tickets, to book flights, to book hotel rooms. If you cannot attend in person, come hang out with me on the Discord and attend virtually. I promise it's still going to be amazing and fun and a great place to connect. And if you think that the chat was super valuable today, you can go save it. Click the little three dots in the top right of your chat and go to save chat. That will let you keep all of your resources. But when these videos end up on YouTube, I do try to get all those resources in the description for you as well. So if there's something you've missed in the past, you can go find it. Thank you, Frank, for hanging out with us today. Thank you, Rachel and Isabella, for helping behind the scenes.
Thank you so much, Frank. Bye,
Yeah,
everybody.